first thing on a stream and I cough. Always a good start. Welcome back. Didn't stream over the weekend. Probably not going to get round to streaming on weekends. Not at least for a few more weeks. So first stream of the week. What did I do? I did do a little bit of coding over the weekend. So I fixed a bug in Alexa, which wasn't a particularly big deal. We added function calls, so we can now pass things like this. Obviously they don't work, we're not doing any interpretation yet. I added comparisons. I improved the printing, so we now have a toStro that takes a ASCII type and returns a char pointer, or putter as people like to say, which basically just gives the name of each type, roughly speaking. So we get output that looks a lot like this, which is just down the bottom here, which is similar to what we had before, except it's now slightly more maintainable. I compressed a few of the nodes. You can see why I've grouped them together because they all have a very similar pattern of printing, with the exception that the node type varies clearly because it's there. I don't know if it's just a cough because I stopped talking, or it's a cough because lingering cold. Let's get rid of that. Let's tidy up some of these. Need a way to report errors. Not done. We are in the process of writing that, which will generate the AST. Now, a couple of interesting things about the abstract syntax tree is I seem to be fluctuating a lot on this. So this is our basic layout. At the moment I've got two structs in my union, anonymous union, which are both working well, but I also had these guys left over, and the function call one ended up making very strong use of children for its arguments. Makes sense, linked list. It's an NRE one, so why not? So I've just taken out the function call because we're not using it. I kind of feel like we've got two systems of doing things. We've got these guys which are dealing with children, and these guys who are dealing with the AST children. Might think about unifying them at some point. I'm going to wait and see how it sort of falls out. We'll probably, once we get to function declarations and things like that, it will work out a lot better. Excuse me. I did a return, but I put it in the atom, which is the wrong place because it's going to be within the atom. It means you could do something like 1 plus return 10, which I could make type check, but excuse me, but it would be a little bit weird. So we're going to, when we get round to writing expressions, which is probably our next step, we'll move the return statement up to there. Right, let's begin. In fact, let's do expressions, which will mean let's do a code block. Yeah. So what are we going to do here? Code block is going to be something like 10 colon 20 colon 50 colon return 60 colon. So we're keeping the language very, very simple, and that, by simple I mean very what people are used to seeing. Planning on, hopefully once we've got something working, then we can start iterating on removing of the pain points. Like, I'm not a super fan of semicolons. I'm quite happy for a new line to indicate an end of an expression, as long as it's clear. But let's keep everything simple, get something working, get some test code written in it so we make sure we don't break anything while we try newer and newer stuff. It may be that I don't mind colons in the end, but I think they're, these days, a bit of syntactic clutter is not needed. Also, chances are that I will eventually say the last statement in any code block returns a value, and it might go off to a void never used thing, which is fine. But go from there. The other thing is sometimes I might just allow non-code blocks, like you might say if x greater than y 10 20, and that might ternary select with this being an expression. But let's focus on the code block. Yes, we need a code block, so we need to parse expressions. You're not going to over here. Close you off. Oh, that's pretty cool. We can do it with the arrows at the bottom. Okay. So here we are at the moment. Let's get that nice and regular. Currently got logical comparisons, which is going to be our top level expression. Oops, AST. Fact statement. That is I think one of these. So it's an expression or a similar statement followed by a semicolon. At the moment, we're only going to allow one, so we're going to call alter stm equals, could inline code, but I think it's worth naming one of these. Expect type. Semicolon. That's pretty good. Believe it or not, that is going to be our entire statement. So it's really just giving a sequence of characters a name. Where we had logical components, we now have there we go. The code blocks consist of that. So let's just put 89 divided by 55. The end. Which obviously doesn't mean anything, it's just a variable lookup. And we need a semicolon there. Everything's a semicolon. But we're not going to put a semicolon on the end of those. Maybe we will. Let's find out. Should close all these down as well, these are dull. My mouse scroll wasn't working. Look at that. I wonder if that's a C-line bug. Or whether we've got some other issues. Let's try killing it. Exit C-line. This has happened before. Saved it. Yep. Let's reload C-line back up. Oh, what happened there was my mouse stopped working. Honestly, it's happened a few times before, and I don't blame C-line for this. I've got a feeling it's here you go, it's working again now. Partially working. Here we go. What is it doing? I should learn some of the keyboard shortcuts for this. I should definitely learn some of the keyboard shortcuts for this. Okay. ST node code. Right at the end, we're going to expect go, so we've got a code block. We're going to need to allocate U, which was node The other thing I did was I was getting annoyed at the iterator, and we want to do more and more with it, so I'll quickly show this. So a tokenizer generates a vector. Let's look here. Let's remind ourselves some of this code. So the tokenizer, which generates L tokens, which contains string IDs, which are in turn strings, the line number, and the token. I can't remember whether I did this online or not, added an ender file, so we got rid of any optional things, which makes, so we don't have to keep checking through if there's something there or not. We can just constantly check if EOF. Simplifies a lot of these statements, because we might say something like, oh, we're expecting a false value. If we get an EOF, it's not a false value, so we don't need to do 2 checks. This returned a vector of LTOX. Then I recently created and then we were using just a straightforward iterator. What I created was a little Lexa class. I know tokenizer and Lexa really mean the same thing, which encompasses the iterator and gives us a slightly abstracted view on the iteration. The advanced would just be the plus and then taking the value of it, which we can see here. What we needed was a peep, so we'll look one ahead, which was actually the main motivation for this, because I didn't want to write this sort of code and roll it back, and it was mixing up too much in the parser, so this makes it a little bit clearer. Current, step back, which I think we use in one place. I might try and reword that at some point. And a few easy accessors, so it just returns the current one. This sort of gives it a dual meaning, but it's very useful. It cuts down a couple of indirections in the explicit parsing code anyway. It's still the same number of steps with the compiler. Okay, code block. Oh, no, we didn't use it. Yeah, that's pretty clear. And God, one day I better speak without my throat going all hoarse. I'm sure there's a trick to it. Create a new code block. Now we need to create a node builder block. This new, maybe, because I was using linked lists a lot. I just added a little helper class that let me add a child. It tracks the last node and just adds to it. There's a singly linked list. A thing with siblings. So in this case, we're going to keep on adding a child to the code block. So one of that weird navigation side program on Windows and Linux. My laptop's Linux and my laptop's Windows and my desktop is Linux. Ubuntu, nothing special. You can see it streaming. C-Line has a few different key bindings. So Control A out left on a Windows machine goes back. Control Alt left on Ubuntu does something, but I'm not sure what. But it certainly doesn't need to go back to your previous position, which is quite annoying. I wish they wouldn't do that. So I don't actually know how to go back on the Linux machine. I'm pretty sure I set it up before in the past. And also, if you notice the little area down here, which may be too small to read, I really need to sort out my iNotify again. And whenever I do that, I then end up reinstalling Linux, and then it's not set properly. Again, I would like to see the default number of that just higher, so people don't ever see this stuff. Anyway, right. Now, a block can be empty, so if this expect will have moved it along one, so if x.type, which is that current one, equals outtalk curly go. So if you've got left curly followed by right curly, it's valid, it's an empty block of code. Return the block to indicate it's empty. Now, while do stnode star, we need build. Path statement, and we have a while. So let's run ourselves through that. A code block starts with a curly block, excuse me, starts with a curly block. We create the new node up. If it instantly ends, then we return the block with no children added. Otherwise, we do this little expression. We add the child, we pass a statement, we add it to the builder, which just adds it to the children of the block. And then when we it's not quite right. So we're expect will error while we've got a semicolon. But we expect a semicolon after every one. Right, when in doubt, write it explicitly. Statement will bring the next one back, so let's do lex.type not equal to what I'm going to do is write a few of these things like this, and then we can go through, tidy them up and see how things going. I'm struggling. Logic is not quite working how I wanted it to. I while dot type not equal to then we can do this is slightly redundant. It is redundant, so but it does skip it, so I'm going to leave it in. I could do a Lex Advance, which is what this does anyway. This makes it clear that we're putting a semicolon, and there's a small chance I might refactor this. For instance, when we're in an error mode, we might exit out of the code block. Probably not actually. I'll probably reset here if it's in an error mode. That is that code block done. He says type expected was not found. No surprise. Type expected was not found. We took it in and let's debug it. If I do the right key presses. Okay. Here we go. Expected. We defined this. Curly. Semicolon. Did I really put a syntax error in my No, I did not. This is most strange. Let's make sure we've got the tokens right. To start with, we're going to have a curly, followed by an integer. Yep, followed by a plus, followed by an integer, followed by a semicolon. Good. Followed by a curly, and then finally Sentinel end of file. Yes, we're confident of that part. So the part we're wondering is what is going on in here. Actually, let's simplify. Is that broken again? No, good. It's too complicated. It should still be broken. Unary ops. This is where we're interested. Integer, yep. We advance. Should put us on the semicolon. semicolon. Regular there, stick on the semicolon. Regular there, stick on the semicolon. Expect semicolon, we've already done it. The statement has to have a semicolon. My mistake is here. Even simpler than what I was hoping for. Got a module, but we don't know how to print a code block yet. I could actually just type the string, but I'm trying to move. I see modules doing the same actually. If I put things in the same pattern, and when I'm not so zoomed in so you can see it all, see what I'm typing, you can spot patterns easier, and then I can compress the code in ways that make it less buggy, hopefully. Okay, so now we do for so walking linked list there, we get the first child. This guy checks the child hasn't gone to null, which is indicated at the end of the linked list, and we just keep getting the siblings. Nothing good there. Then we just every time we recur a thing, we increase the indentation level, which is why we're seeing it moving from the left. There we go. Init value 100 plus int phase 200. So we've just implemented code blocks. It's definitely a talking thing. I'm going to have to try and maybe drinks make better than hot tea. Right. Won't check that in right yet. So now we've got statement. Well, we want to move the return, which is in our echo. Find it. This. Switch. Okay, so now this statement string is going to go out a little bit bigger now. By default, so that isn't all we've got to finish with a semicolon. originally put the return up as an expression in the atom function was I was thinking about if else's, which I don't know if anyone uses C9 much, but the double tapping the shift brings up this find everything, which is how I've been jumping around. STMain, which finds functions, structs, files, anything you want. So when I want to go to Atom, I just do that, and it's there. It's very useful. And, other editors do that sort of thing as well. But I haven't seen any make use of double tapping the shift, which is a really nice place to put it. It's much better than Control P for searching for things, and, Control T and Visual Studio. Well done. Now the obvious thing is let's put a return statement in here. Make sure we haven't broken anything. There is a small. You see the return. Code blocks done. Don't need LOL there anymore. If expressions, while expressions, function definitions. We're working our way up there. I think we've done true and false. Got our lookups. We might need to roll in, well, these are going to be in the function defs. Which will probably be the last. Oh no, it won't. In fact, let's do that now. Excuse me. At the moment we're going to say let's do variable definitions. A variable definition is going to be a statement, because, you know, why wouldn't it be? We could have it returning the last value, but that would lead us to the if style things you see in C++, along with the new, I don't know what they call it, the filtering thing where you put a semicolon and got a logical expression on the right hand side. C++ 17. I'm more inclined to restrict the expressions of if to balls, which, you know, is what a lot of other languages do. C# does it, obviously C doesn't. I think Dart does it. No idea about Perl 6. I wonder what Rust does. I imagine Rust does as well. What was it? Keyword let. Let's going to be the way we declare functions. So the format is let identifier colon type equals expression. You must have expression. Eventually, in fact, we might actually let will for now it doesn't. This is the only format we're going to accept. It'll help if I can type properly. Identifier, colon. So the current plan is, well, we see a colon within the code. We're going to say, going to read that as has type. Yeah. How are we doing for time? It's 9:50 in the UK. Probably not going to go much past 10 o'clock. And but let's see how far we get. So next stop. Skip the keyword. Next is we need an identifier. So now if we don't have this will be 0. 0 is our null value for string ID, so we're good with that. Expect to move us over and generate an error if we're expecting a identifier, so correctly, yep. Then where are we? I would imagine eventually I will a message start supplying our own message, so rather than just getting a message that says, hey, well at the moment it says didn't get what you expected, it will say something like, it won't say colon expected, it will say, you know, type declaration expected, type declaration of a variable expected, or something like that. So all I want to do is lay down some groundwork so that we can improve the messaging as we go along. Messaging is important. Right, next is a type. Now, at the moment, we're not allowing custom types. Currently don't allow custom types. Now we scroll up here, these are the ones that we support. Seems a bit limited. I'm pretty sure our tokenizer supports more than that. Void. That will be more important when we more important for function declaration. It's not going to be able to do a let void, but we will let you type void there, and then the type checker will catch it, because you won't be able to cast a Right, where are we there? don't think we should get here, but let's put something if we do. Oh God, excuse me. How do people talk continuously for this long? Some people seem to do it for ages. Where were we? We know where we were. We're in statement. We're just going to put handle type. We have to create a little structure for that in a second. So let's start. Advanced, just get ourselves over that. To type. Eventually the colon and the type will become optional, but not in version 0.1. Where are we? So we just moved past the type, and now we expect it's an assignment. Skip over that and auto. So what do we need in here? We need a struct. We need an struct ID name of our local variable. Definition. We need struct type contains stuff. Type. This is going to be things like built-in and so on. We need an AST node init. That is all we need. Right, so this guy is already in a node, so it seems pointless to create a variable definition for that. Type. Well, we're going to be doing type checking, which means we're going to, on every single AST node, is going to have a type, which could be void, could be anything. So when we compare two types, we initialize them, which means type has got to sit. There's no point putting it in the union because every single one's going to be given that. I haven't quite decided how that's going to work yet. So all we're left with, do we want a variable definition structure just to hold the initial expression? Well, you could do that as a child. This is where the mix up between whether or not we want a structure or a child. Guess what we're going to do? Node. I know it's very annoying. Very annoying that I also talk when I type. And oh, that's pretty cool. I'm watching. I'm good with that. Right, type true. Really good. You know what? That should be called kind. That avoids this problem. Right, we're about to embark on a bit of a refactor. So let's check it compiles. It does. 6. Kind. So easy. 10 years ago. Oh, I wanted to do refactor, thank you. There we go. Didn't catch that, did it? That's because it's a different token. But we want to have things consistent, don't we? Which means making that a kind. That all goes well. It's a very quick renaming. Back to here. Now we can do type of. That's fine. I think we know you're not used to the moment. Built-in. No. Quite decided how this is going to work here. Kind. Don't like that. Probably going to have to do an enum here. Enum. You know what? I'm not going to worry about that yet. Let's get the other bit working first. initialization. So, my second screen, so. Got to remember we're only supporting a few types at the moment, so given the time, I think I'm going to leave it there, and I may continue in the evening later on, or it'll be there if I get around to streaming tomorrow. So what did we do today? We added a code block. We did a bit of a rename refactoring. We pretty much decided that we're going the linked list way for most things because they just seem to be falling out. We may end up going a union way if we want to save size on the AST, but I can't see that happening at the moment. That's all good. And we started work on the variable definition. Got to think about what we're going to do with the types. So, GUI. And I've got to stop speaking as I type. That is pretty much what we're going to do for team type. That doesn't fit with our naming style, does it? Kind. Everything should be a kind. Type. Kind. And we can do type. User defined. Type's going to be a regular theme in what we want to gradually expand. At the moment we're just going to have, we've only got built-in ones, but when we get user-defined ones, you'll be able to declare types in functions or within module scopes or within other modules, you'll be able to import them and who knows what. But initially, which means we will need a linked, we will need lookup and tables to store them and search orders. You know, we'd search the local scope first, then we'd go to the module scope, then we'd go to other imported modules. If they import things, you could import things into the module scope, so you need a whole type E hierarchy. We're not going to do that just yet. Here we go, that's not going to be used. And we're just going to keep eventually have a strut. I'm just going to ID. That would store the name of the type. so we can look things up. I guess eventually, along with the type, we need a symbol table. We'll probably end up with those sort of types. I think this type thing will morph into a symbol table. That way we can check that there's, when we do each scope will need its own symbol table. It's slowly going back to me this sort of parsy stuff. It's been a little while since I wrote one. Each scope will need a symbol table. It will need to know where its parent is, and then we will be able to split that stuff up. Fill in the symbols as we parse them, or probably a second walk. From that we'll be able to infer types. No, check types. I'm not going to infer types. I'm going to leave it for now. This may symbol table is just a hash map that will take some key, which will more than likely be a string ID, because the only things you're going to want to look up are strings. So it will take our integer ID to a string, and it will return some information describing that object. At the moment it will just be a type, so we may as well store the type here. We'll see how it goes. The problem with that is that we can't, if we do y equals x, we can't check the types are the same because we wouldn't know where to find x, so it does need a symbol table. We might end up storing the AST pointer. That'd be a bit nuts, wouldn't it? Yeah. Anyway, I'm going to call that a night. Might get streamed tomorrow, depending. It's training night tomorrow, so depends how tired I come back. I might actually code some more later on, but for now it's time for a cup of tea. Okay, thanks for, well, nobody's watching, so thanks for not watching. And I shall see you tomorrow, or the following day. Right, thanks, bye.